different types of convergent plate boundary. In convergent plate boundary, the lithospheric plates are moving towards each other, where one leading edge of a plate will be subducted and turned into magma. Just like in the convergence of oceanic to continental crustal plates, that gives rise to the formation of trenches, volcanic arc, and earthquakes. In convergence of oceanic to oceanic crustal plates, it leads to the formation of trenches, volcanic island arcs, and strong earthquakes that can generate tsunamis like what happened in Japan in 2011. In the last type of convergent plate boundary, where two continental crustal plates collide, there is no subduction zone. Therefore, no volcanoes, but rather a collision zone happens that create mountain ranges and shallow earthquakes. Divergent plate boundary is when the lithospheric plates are moving apart from each other. If the divergent movement is happening in the oceanic plates, it can lead to the formation of the oceanic ridge and reef valley. Divergent plate movement can also occur in continental plates. As continental plate starts to move apart, the crust will start thinning and develops a continental reef valley. The continental reef valley will develop into a narrow sea and then into a widened ocean. Transform fault plate boundary. Let's examine the simulation above. If the blocks represent the lithospheric plates, you will notice that there were two sets of divergent plate boundaries between blocks 1 and 2 and blocks 3 and 4. But since the plates were adjacent to each other, a new type of boundary is manifested, and that is the transform fault boundary between blocks 2 and 3. The presence of an oceanic ridge is an indication of diverging plates, and as the plates diverge between the two segments of the mid-ocean ridge, the adjacent slabs of crust are grinding past each other, forming transform fault. Transform boundaries and the resulting faults produce many earthquakes because edges of tectonic plates are jagged rather than smooth. As the plates grind past each other, the jagged edges strike each other, catch, and stick, locking the plates in place for a time. Because the plates are locked together without moving, a lot of stress builds up at the fault line. This stress is released in quick bursts when the plates suddenly slip into new positions. The sudden movement is what we feel as the shaking and trembling of an earthquake.